Hello, everybody, and welcome to lesson 5.5 in your textbook on page 322. And this is on solving exponential equations. So these are equations that have a variable as an exponent. So remember, we have 2 to the power of x. This is what we're talking about. So the variable is an exponent. And there's the way we're going to solve it, there's so many ways to solve exponential equations. The simplest one that I'm going to show you today is when you can make the bases the same. If you can't make the bases the same, this won't work. And I'll explain what bases are again. So remember, watch the if you have a variable, a power, let's say you have 3 to the power of 2, 3 squared. This right here is your base. And that's what I'm talking about. So I'm not talking about the power, the exponent. I'm talking about the base, the number that's below the power, below the exponent, yeah? If this is the same on both sides of the equal sign, then you can use the method of dropping out the bases that are the same and making the exponents equal to each other. If the bases are the same, you can drop them out and the exponents must be equal to each other. And in this case, it would mean x is 2 because they're equal to each other. So this is kind of the gist or the overview of what we're going to do to solve these equations. So you have to have a good grasp on number sense. And I gave you an IXL assignment that kind of helps you work that number sense. And it's called exponents. So look at that. I believe I put it on today, which is October 5th. And so we're looking at solving exponential equations. And down here on the bottom of the page, let's look at, don't worry about all this. This looks very complicated. I don't want you to get confused. So, but here's what I talked about. You can solve many exponential equations. Remember, only if you can make the bases the same can make this work. It doesn't always work that way. So a lot of them you can. That's why they're saying many, by writing each side of the equation. Remember, an equation has an equal sign and something on the left and something on the right side with the same base. So this is what we're going to do, okay? Now, what does it say down here? Same base than the exponent. When an exponential equation has the same base on each side of the equation, then the exponents must be equal. This is what I was talking about up here. If you have the same base on both sides of the equal sign, you can just drop them out and set the exponents equal to each other. Most of the time, have the solution right away. Okay, that's what this says here. So then it's talking about b is greater than 0. B can be 1. This B stands for base. Yeah, so the base has to be positive, that says, and the base cannot be 1. That's all that says, okay? And let's move on to the next page. And we're looking at problem 1. Let's see what is the solution. So we're looking for x. See, notice this is an exponential equation. The x is your exponent. It's higher than the base. Base is 7. So somehow we have to make 343 and turn it into some power base 7. Yeah. So let's look what they're saying over here. How can you rewrite the constant in each equation to help you solve it? So the constant is this right here. How can I and you always want to make it the smaller number. 7 is the smaller number. How can I change 343 to base 7. And you need your calculator for that. If you have your calculator handy, get it now, pause the video. We want to find out 7 times 7. How many times do I multiply 7 together to get to 343? That's what that means, yeah, base 7. So 7 times 7 is 49. I already know that. 49 times 7 is 343. So you just have to kind of play around with your calculator. You're using the 7, the lower base, right? And you're going to multiply it until you get to this number, right? So 343 is equal to 7 to the power of 3. So this is base 7 now. So I changed it. These are equal. So 7 to the power of x is 7 to the power of 3. And so I can drop out the bases because they're the same, and I can set the exponents equal to each other, and then I have my solution. Okay, so check it out. 7 to the power of 3 is indeed 343. Try it out. Use your calculator, use your power key. Remember the power key is that caret. 7 power of 3, don't forget equals 343. So now we found x. I'm going to skip down here to show you just one more, like this. 9 to the power of x. So this is base 9. You want to change 729 to base 9. So you're going to put 9 in your calculator and times it by itself. And when you do that, you're going to get 81. Well, it's not enough, right? So try it again. 9 times 9 times 9, and you'll see that it's 729, right? So 9 cubed is 729. So 9 to the power of x is the same as 9 to the power of 3. Drop out the same bases and set the exponents equal to each other. And then you have your solution. Okay. Now we're going to look at a fraction here. Do you remember from, I believe it was 5 point, where you learned about negative exponents that turn into a fraction, right? So this is what's going to happen about the fraction, right? So we want to look at base 6. Take 216 first. Just take this number. Ignore the fraction. Right now, we're going to ignore the fraction. We want to make it base 6. And I believe it's 6 to the power of 3. If you put base 6 in the calculator, 6 times 6 is 36. Try it again, times 6, until you get to 216. So that's it. But it's 1 over 6 to the power of 3. So now we cannot just drop it out because this right here is in the way. So, but I know that that's 6 to the power of negative 3. So anytime you have a fraction like this, you're going to get a negative exponent. Look at lesson 5.1 again. Bases are the same, drop them out, and therefore x has to be negative 3. Exponents are equal. Okay. I can tell you to please pause the video, take your notes, don't rush. Let it sink in. Try to understand what's going on. Just copying the notes is just not going to do it. I would go over each step and look at it and go, how did it go from here to here? What happened? And from here to here, what happened? So step by step. And now let's look at this one, C. Again, look at the fraction. I already know it's going to be something with a negative power. And then you see, but it's going to be, I'm going to take 1024 first. I want to make it base 2. You always look at the power here, base 2. So how can I turn 1024 into multiplying 2 repeatedly? That's going to be a lot of them. I think there's actually 10 of them. You got to just practice with your calculator. Use a power key and see 2, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 2 to the power of 10, right? So now, but remember, it's the one under. So 2 to the power of 10 is in the bottom of a fraction, and this is not a fraction. So I have to kind of fix it. You cannot just drop it out now because this is not the same base. So what do? I'll make this, bring it to the top, and make the exponent negative. And the bases are the same. And then you can set the exponents equal to each other. And then you have to solve for x. Subtract 4 from both sides and bring down the x. Negative 10 plus negative 4 is negative 14. Okay, so that's how this works, this part of the lesson. So let's move on. Real world exponential equations. We're on page 324. Real world always stands for word problem. Okay, so the function r of x equals 2 to the power of x. It's an exponential function because our variable is a exponent. Represents the number of regions formed when you fold a tablecloth x times, meaning many times. X can be any folds, 1 fold, 2 fold. How many folds do you need? Okay, so how many folds do you need to make 128 regions? So I started this one with a picture of a tablecloth. Usually they're rectangle. So if you fold it over, you're gonna fold it in half, right? That's 1 fold. So x is 1 here. 1 fold. First of all, x is 0 when you look at the whole tablecloth. When the tablecloth is intact, x is 0, which makes not much sense in the context of our problem, but that's what that means. So now the first fold, fold it over. Now you got half of it, right? Half of the tablecloth, it's half big. So now you're gonna fold that in half again. So that means x is 2. And so you're folding it this way, right? And what do you have left? The lower half. You can take that and do it at home and try that yourself. So now you have, this is folded over, so you got this right here. So now we're gonna have x is 3, fold it again in half. Now you got, so you folded it this way. Now you got that part left. And so on and so forth. You get the idea. Now I fold that in half. That's x is 4. We want to know how many folds do you need to make 128 regions. So you got 1, 2, 3, 4. No, wait. 1, 2, 3, 4. I would say that's how we're going to count them. So the R stands for regions. So that number here needs to be 128 because we want to know x. Yeah, so the regions, we want to know how many folds. X is the number of folds. I'll write that over here. Okay, now remember we want to make the bases the same, so I'm going to change 128 into base 2. And I already practiced with my calculator how to find how many 2's do I multiply to get to 128. It's 7. So 2 to the power of 7 is 2 to the power of x. And I can drop out the 2's because they're the same. You can only drop them out when they're the same. So the tops get equal. So it's 7 folds. With 7 folds, you'll have 128 regions. You can try that maybe. I would say this counts as a region. 1, 2, and then because that's a lot, 7 folds, 128. I think each one, so that would be 2 regions, and then we'd have 4 more. Imagine you have the whole tablecloth, right? It's gonna make 4 regions, and then let's say if you have the whole tablecloth here, I should probably draw it like that. Now you have 1, 2, 3, 4, 5, 6, so 8 regions. I think that's what they're talking about now that I'm looking at it closer. You can try this with a piece of paper. That makes it easier. But you have to have a pretty big paper to get 128 regions. So that was that application. Now let's look at archaeology on the bottom. So in archaeology, this function f of x is 3 to the power of x plus 2, models the number of fossils an archaeologist finds after x years. So x is the number of years. According to the model, after how many years, so we're looking for x, this is what that means, will the archaeologist find 81 fossils? Well, that's the number of fossils, so that needs to be 81. And we're looking for years, so this is the x is what we're looking for. So the way we're going to do it is we're going to try to make 81 into base 3. And if you use your calculator and you multiply 3 times 3 times 3 times 3 4 times, you're going to get 81. And if you say, well, how do you know all that? Well, because you've got to try it. I don't. I put that number in my calculator. I actually use my power key and just go 3 to the power of 3 is 27. And then I see 27 times 3 would be 81. I have a good number sense. So then I know it's 3 to the power of 4. I just play around with it with a calculator. So now bases can be dropped out, exponents, set them equal to each other and solve for x. So after 2 years, they have 81 fossils, according to this model. By the way, what's a fossil? A fossil is one of those dead things that are in the ground that you dig up and find, usually like old dead fish or snail shells or something like that. That's a fossil. If it's like really old, like almost, turned into stone. And next page, we have, oh yeah, on the top. Now we're going to use Desmos. So you can solve an exponential equation by graphing each side of the equation. We've done it before. The solution is the x-coordinate, remember the x-coordinate, of the point of intersections of the two graphs. So wherever the graphs intersect, that number, you want the first one. Yeah, the x. So when you graph it, you want to make, see how you have an equation here? You have a left side and a right side. So you're going to put a y in front of the left side and a y in front of the right side. And you graph both of these in the same coordinate plane and see where they intersect. So we're going to do that real quick, and I'm going to pause. Okay, so we're on Desmos, and the first equation, y equals 3, looks like this. The second equation, instead of that multiplication button, I use parentheses, and then the power of x, you have to use your little function, the keypad down here on the left bottom, and you have to use a to the power of b. That's your key here, all right? And notice that the line y equals 3 is a horizontal line through 3 on the y-axis. But that's not what we're looking for. We're looking for the point of intersection. The blue one is your exponential graph. It's curved and it goes straight up. It grows pretty fast. So the x is -1. You want the x value, right? Okay, back to the lesson. So after we graph them together, the point of the intersection of where both lines intersected was -1, I believe it was 3, yep. And it's the x value, which is the first number. This is the one you want. And so x equals -1 is the answer. By the way, you can solve any equation with the graphing, what I just showed you. Graph both sides, set a y in front of it, see where they intersect. It always works. And now let's look at what to do when we want to check. How can you check? So you're going to plug in or substitute x is -1 into the problem. So we're going to rewrite the problem. 3 equals 9 times 3 to the power of -1 minus 2, right? X minus 2, -1. That's -3. 3 equals 9 times 3 to the power of -3. The negative power needs to be made into a fraction. 1 over, it's 27, by the way. 3 to the power of 3 is 27. 3 times 3 is 9, times 3 is 27. 9 times 1/27 is 9. Whoop, this doesn't work out. That doesn't look right. We got our x-intercept, 9 times 3. What did I do wrong? Was it -1? Yeah. That's 1 over. That's not correct. Well, I'm sure some of you see where I went wrong. 1 over 27, 9 times 1 over 20, that's 1/3. This right here is 1/3. Or was it 1? I gotta check. Maybe I remember the wrong. Okay, I see the mistake I made. If you notice, the second equation I put in says x. It needs to be what? X minus 2. So we got to fix that. A to the power of b. And I'm going to try, let's see if it works if I just put it in like that. Nope. Got to use parentheses. Otherwise, it will not know to group the x minus 2. There it is. Okay, that makes more sense. Now, notice that now my intercept is 1, which is the number that actually works. So mistake, sorry about that, guys. I didn't put in my equation correctly. So notice x is 1. Now, let's make sure I'm sharing all this correctly. I think I am. Okay, so if x is 1, this is why we can check, see? Good thing we checked. I would have showed you something wrong. If x is +1 or 1, when I plug in 1 over here, and I'm just going to fix my mistake. Notice how I don't erase everything in math. That's why you show your work. You don't have to always erase and start from scratch. If you know where your mistake is. 1 minus 2 is not -3, it's -1. And 3 to the power of -1 is 1/3, 1 over 3. And 9 over 3, 9 times 1/3 is 1/3 of 9, or 9 divided by 3. 9 divided by 3 is indeed 3. So now it checks. Very good. Well, there you saw how you make a mistake, and you can check and make sure that you figure out where it's wrong. That's why I give you a lot of homework questions that say find the mistake, because it's good to look, where did I go wrong? And that happens a lot in math. You don't have to be perfect. Okay? And we're done with this lesson. So here's our homework. So we're on page 326. And you're going to do 7, solve each exponential equation, just like the first example. You want to write base 3. How many 3's do you multiply together to get to 729? And then the same with 8, you need to write 512 as a base 2 power. This one, 1/8, remember, if it's a fraction, you're going to have to make a negative exponent. Look at the example I gave you. Same in number 10, it's a fraction. You're going to end up with a negative power here. Yeah? Then I have a word problem. And this is just like the one with the folding tablecloth or with the fossils. Go look at that, okay? Ooh, this is going to be interesting. You're going to have to make this number base 8. So you're going to probably want to use your power key to find out 8 to what power. Yeah. Then reasoning, how do you find, how did I show you how to find the solution by graphing? I just showed you, right? Look at that. And on the next page, an error. There you go. Error, what is the mistake? This is the answer they found, but it's really not. You have to figure out what the answer is really, and then you can see where the mistake is when you write it all down. And then on the bottom, number 24 is the same as the fossil problem. And then one more on the back page that is for if you really love math, is number 28, challenge. Yeah? So if Peter earned 1 cent the first day, 2 cents the next day, 4 cents, it always looks like it's doubling. After how many days will Peter earn a total of $329.67? The first thing I would look at is how many cents are in this, yeah? Because here it's talking about cents, now it's changed to dollars. So we got 2 different units. So you kind of have to think about that. And this is a challenge question, so it's kind of good to have those. I'll see you guys. Good luck on this.